In this video, we're going to be talking about point-slope form of an equation and how to use it to write linear equations. So first we need to talk about the structure of the point-slope form. So the point-slope form is here. Oops, didn't mean to draw on that. It's y minus y1 equals m times x minus x1. Now the y1, oops, my marker's not working. The y1 is the y-coordinate of a point, and the x1 is the x-coordinate of a point. The m is still slope, just like in the slope-intercept form. So in the slope-intercept form, y equals mx plus b, we needed a slope and a y-intercept, hence the name, slope-intercept form. In the point-slope form, we need a point and a slope in order to write the equation. Again, hence the name, point-slope form. Looking at this first example, it says, find an equation of the line with a slope of negative 1/4. We already have m. M is negative 1/4. And passes through the point 3, 1. Now we have our point. Write in point-slope form. So on this example, we have all the information we need. To write it in point-slope form, we needed a point and a slope, and we have it. We just fill in where it needs to go. X and Y without the subscript here. So the y1 and the x1 are from the point. The y without the subscript and the x without the subscript, those are still just variables. We leave them as y and x. So filling it in, I have y minus, my y1 is 1, equals m was negative 1/4, times the quantity, x stays a variable, minus x1, which was 3. And since it said to leave it in point-slope form, that's all I need to do. Now let's look at the next example. It says, find an equation of a line with a slope of negative 2 and passes through the point negative 5, 3. Write in point-slope form and slope-intercept form. We're going to start with the point-slope form since we have our point and our slope. We know that m is going to be negative 2, and we have our x1 and y1. I'm going to fill it into my equation. Y minus y1 was 3 equals m, which is negative 2, times x minus x1. So don't lose your negatives. It is x minus a negative 5. So when I subtract the negative, that is going to become plus. I'm just going to go ahead and write one more step to show that. So a negative times a negative, or subtracting a negative, is the same thing as adding a positive. Alright, so that is the point-slope form. But it also says that we need to write it in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. Now we don't need to do any extra work to find b. We already have an equation. We just need to solve that equation for y. I'm going to start by distributing the 2. So negative 2 times x and negative 2 times positive 5. I'll get negative 2x, and then negative 2 times 5 would be negative 10. Lastly, I still need to get y alone, so I'm going to add 3 to both sides. And I'd end up with y equals negative 2x, and negative 10 plus 3 will be negative 7. And now it's in slope-intercept form. Let's look at this next example. This next one says, find an equation of a line that passes through the point 6, 1 and 8, 9, right in point slope form. Now, in this example, we don't have a slope. We need to write it in point slope form. We need a point and we need a slope. We have a point, we have multiple points. We do not have a slope. So I'm going to use my slope equation. M equals y2 minus y1 divided by x2 minus x1. And I fill it in. I'm going to go ahead and label these as x1, y1, x2, y2. Again, I could flip-flop those. Doesn't matter which point is the first point, which one is the second point. Filling in my equation, y2 is 9 minus y1 is 1 divided by x2 is 8 minus x1 is 6. 9 minus 1 is 8. 8 minus 6 is 2. 8 divided by 2 is 4. We should always be simplifying fractions down as far as they go. Now that I have a slope and multiple points, I can fill in my equation. There's multiple ways to do this since I have 2 points. I could use the first point, filling it in as y minus y1 is 1 equals my slope of 4 times the quantity x minus x1, which is 6. That is one way you could do it and leave it in point slope form. But I could also use the other point. It doesn't matter which point you choose, they are both on the line. All I need is a point on the line and a slope. So I could also have chosen to do y minus 9 equals 4 times x minus 8. These are equivalent. If I solved both of these for y, I'd end up with the same slope-intercept form. So either one of these are acceptable answers if you're asked to leave it in the point slope form. Why don't you try the next one? Alright. This next example is similar to the one above. It says we want to write the equation of a line given these 2 points, and we want to write the answer in point slope form. So again, you could have chosen either point to be the first point, and then the other one is the second point. I have to find my slope first because I need a point and a slope for this equation. I fill in what I know. So y2 is 28 minus y1 is 3 divided by x2 is 15 minus x1, which is negative 5. Again, don't lose those signs. I am subtracting a negative number. I have 2 negatives here. When I simplify, 28 minus 3 is 25. I'll have 15 minus a negative 5. Those 2 negatives become a positive. So 15 plus 5 is now 20. I need to write my fraction in lowest terms. It's not going to be a whole number this time, but I could divide out a common factor of 5. So 25 divided by 5 is 5. 20 divided by 5 is 4. There's my slope. Now I fill in the point slope form because I have a slope and I have some points. Y minus y1 is 3 equals my slope, 5/4, times x minus x1, which is negative 5. And then I'm just going to go ahead and simplify that by changing that, subtracting a negative to x plus 5. So that would be if I chose the first point for my x1, y1. I could have also chosen the second point. So another possible solution would be y minus the other y, so 28, equals my slope, still 5/4, times x minus the other x coordinate, which is 15. So that would also be a possible solution. Alright, so there you go. Point slope form, y minus y1 equals m times the quantity x minus x1.